Where's the mouse? Give me the mouse. All right, look at this. This is how you measure the mass. No, not measure the mass. Measure the volume.
Where is the
Get off your
phone?
phone. Measure. Yes, you don't have to ask ChatGPT. You can ask me.
And I have to read English.
I
Translated this page
So
into English sentences.
anyway.
I have to watch it and watch that.
Anyway, how if you want to measure a rock like this? How do you measure rock like this? What's the
By
formula? I have no idea. So we're gonna use a eureka. A eureka is something like this. The shape will be like something like this. Be like this. Forgive my terrible art. Eureka's like this. You want to fill the eureka with like this amount of water. So for example, this is the water. This is the water. Then you want to drop the object in, then the water's gonna spill out and into this beaker. And from there you can measure the volume. Okay? Do you guys know? Let's get on to the next page.
I just know Tita.
Oh,
I never know about it before.
Okay, come on. First one. To find the boiling point of two liquids. We have substance A and B. If we were to give heat to these two substances and measure the temperature of the substances, you see. Look at this. Look at substance A and B. Look at this. 44, 55, 66, 76, 84, 92. Before you decide, after like 5 minutes, 5.3 minutes, look at this. 100, 100, 100, 100, 100. What does this mean? This means that A is concluded a pure substance. Am I right or wrong? Let's see. Look at this. A is a pure substance, so I'm right. If A was a pure substance, B is probably not. Look at this. 49, then it suddenly comes to 60. Then it comes to 75, then 81, 86, 88, 89. It's not a pure substance.
It's not constant.
It's
The
a heterogeneous substance. Yeah, I'm too lazy to write it.
Because boiling temperature is not constant, right?
So we want to look at this. I'm correct. Look, A is a pure substance, and B is a heterogeneous substance. All right, we're gonna erase this. So lazy. Let's go. Look at this. We wanna look at this. This is it's like a pretest. An explorer wants to hop on a hot air balloon filled with helium. Now, what is helium? Helium is this gas. This is the chemical formula. Helium is commonly used in balloons. If you fill a balloon with helium, it will float up because helium is less dense than oxygen or nitrogen, all the stuff in air. So that's the reason why helium makes balloons float up. As you can see, he filled the hot air balloon with 500 cubic meters of helium and has 60 kilograms, 60 mass of 60 kilograms in the balloon. How much is the density? We use the same formula. D equals, what is it? M and and V. Yes, D equals MV. So then D equals 600 divided by 500. Let's see.
60, not 600.
60. I said wrong, sorry.
I'm listening to you.
Okay. We're gonna add one that's zero from the start because we don't really have the amount of enough numbers. 1.12, 0.112. There's the answer, 0.112. Perfect. Now we're gonna look at this. We need line. Yes. Perfect. Okay. Scroll down. Oh, my line. Okay, let's look at this. It says Shaoxing.
Density of an object.
What is the density of an object? It's how to find the density of an object. D equals mv. M divided by volume. Is it correct? Yes. Let's go to the next one. Next one is กอไก่ So, uh, the substance floats in water. That means that that substance is less dense than water. If the object sinks in water, that means the density is more than water. Skip 4. Let's look at this first. It's ขอไข่. Let's look at ขอไข่. ขอไข่is density equals the density of water. That's correct because if an object floats like this, there'll be 3 stages of floating. All right, 3 beakers. Hello. Okay, all right, 3 beakers here. 1, 2, 3. This is the water. If the object floats above the water, the object is less dense. If the object sinks, that means the object is more dense. But if the object is something like this, that means the object has the same density as water.
Object. Density of the object.
Okay, back to the choices. Now look at this. How to make the volume less. No, how to make the density less. We want to add more volume. You know why? Look at those ships. For example, let's take an example of the Titanic. Titanic was a passenger ship in 1912. It was huge. Aluminum sinks in water, so does metal or silver or any large metals. But why does the Titanic float in water? The Titanic was huge. It spread mass and weight all over the substance of the water, so it balances and it makes it less dense. You all guys understand? I think you do. Now look at 7.
Make the density less than the density of water?
Huh? It makes the density less dense. So now it can float on water.
It's so huge, the Titanic boat.
Yes, that's why it can float. It doesn't make sense.
The Saturn can float on water.
Yes, Saturn can float on water because Saturn is a planet with very less density. Come look at this. Now number 7 we have 要引. 要引 is if we want to make a less dense object sink in water, we have to add the volume until it has. No, hold on. I translated wrong. How to make an object that sinks, make it float. Add the density until it has less density than 1 gram per centimeter per cubic centimeter. Why is it this? Because water, where's my pen? Oh, water has a density of 0.99 grams centimeter third. That's why you need to add the volume, add, and then add it until there's no more to add. Or maybe there's until it floats. Yeah. Okay, let's go to the next page. Look at this. We want to stamp. Stamp. Yes, I need to stamp. Yeah, tick stamp. From the information in this graph, let's see which one is correct and which one is wrong. Plastic floats in water but sinks in petroleum. Correct. Why? Because Because plastic, it is less denser than water. But since petroleum is also less denser than water, petroleum is also less denser than the plastic. So that's why the plastic sinks. Said wrong. Okay. Cross, you should know because look at this. Plastic, a square plastic with a mass of 50 grams floats. If the plastic uh had 1 kilogram of mass, it won't float. Wrong. It will make it sink even more. If it has more mass, that means more volume, and more volume means less density. Oh, wrong. If we pour petroleum into water, the petroleum will float on the water, correct? But if we pour milk into petroleum, it will go under. No, wrong, because milk is even denser than water. I guess a little bit denser than water.
Petroleum, we call it ethanol.
Yes, it's oil. Just call it oil.
Ethanol.
I want to call it oil. Freak ethanol. I want to call it oil.
We will call it ethanol.
But I want to call it oil. It's still oil.
Everyone will understand. Ethanol will separate and float on top.
Ooh, wrong. We have a
How about graph?
we have a chemical bottle. The bottle isn't made of chemicals, but it has chemicals in it. You know what I mean. So we have a bottle full of chemicals. It's white and no color, and it's a solid. It's white and it has no color. If we go test it and we find the melting point, it starts to melt at 156 Celsius and it finishes melting at 156.5. Look at this. This is a clue. Because a pure substance has a narrow melting point, I'm gonna guess it's a pure substance.
This
What?
one.
Am I correct? Yes.
This one, odorless.
Odorless. No smell. Let's go to the next. This is
Water,
yes.
mouth spray.
My neck is gonna die today.
Why so hard, teacher?
You have a comfortable chair. Look at my chair. Hiya. Let's go. Look at this. Number 2. This is a graph. Put all the three liquids. Put them to boil.
3 types of liquid.
3 types of liquids. Put them to boil and record the temperature every 3 minutes. Then we want to
Use
put
the
the
data.
information and use data and
Put
make
a graph.
a graph. Yeah, you know it. Let's see which one is correct. By looking at the graph, let's look at the questions. First, substance A is a heterogeneous substance. Oh, see about that. This is substance A. It's blue. Let's see. Look at this. Up, 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 up. Okay? Up, 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 and then it's stable, 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 and then up, 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 and then up, 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 up. That means it is a heterogeneous substance. But what about B and C? Is it a pure substance? This is B, this is C. Okay, let's see. B is this up, 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 and then it stables. No, this is C. C is stable, but B, what about B? No, it's not stable. So I'm gonna guess it's called height because it says C is a pure substance, A and B is a heterogeneous substance. I think so. What does it say? See?
B is
I'm
a
correct.
pure substance.
I'm the smartest teacher ever.
Why?
Huh?
Why?
Look at the melting points. Look at A and B. A has an unstable melting point. See how it goes up and then up, 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 up. Look at B. It also is unstable. You might think that these short periods of stableness means that it's stable. No. Look at the end. Still going up. Up, 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 up. Look at that.
Mm.
So it answers, so the answer is called high because C is a pure substance. Look at it. The substance is stable once it hits 60. Okay, let's go to the next page.
Only the substance C shows the constant boiling points at the end, right?
Yes, I'm so lazy. D has a melting point and a hold on. Much better. D has a boiling point and a melting point at which wait, which at which temperature? This is such an easy question. If if you guys don't know this question, I don't know how am I gonna teach you. Just look at the graph, all right? This is D.
I'm looking at
And
it.
look. This is the melting point. Melting point is 60. Boiling point is 80. See? Correct. I'm so smart.
Melting point.
Melting point is 60. And boiling point is 80. You see?
Ah,
Okay, let's go.
look at the end of the graph only.
Yes. Which one is correct? Uh, Substance A has a higher boiling point than C and D. Let's go see if it's true.
It's not like in my test.
Yes. Your test literally copied this one. You're so lazy.
Don't you think she copied me?
No, she
Your
didn't.
teacher copied me.
She doesn't even know you.
How could
Hiya.
I know her?
Hiya. So dumb. Okay. A has a higher melting point than C and D. This is A's melting point. And look at C and D. No, C and D is higher. So this is wrong. Wrong. A has a lower melting point than B, C, and D. Lower melting point. Let's see if it's true. Lower melting point than B, C. No, B is lower. Let's go to D. I'm gonna skip this one. I'm too lazy. All right. C has a higher melting point than B and lower melting point than D. Higher melting point than D. Wait, hold on. Higher melting point than B, lower melting point than D. Yes, correct. So we're gonna answer yes, and it's correct. I'm so smart. Okay, let's look at number 5. It wants us to look at the graph. If we put all three of these and put it into cooking oil, which one will float? Actually, a lot of you guys get tricked in this question. You will immediately answer A and B. No, that's wrong. Look at my explanation. Because you guys get tricked, but look at this. Look at B and C. Look, this is around 2.8, and this is 2. This is 1, and this is 1. Which one is near? Which one is more near? This one, B, right? Now look at C. This is also around 4.8. And this is around no, this is 3.8 and this is 3. So I'm not gonna think. I'm way too lazy. I'm gonna say that it is called Huai because the look at this. It's so near together. It's not that far as 1 and 1 as A. So I'm gonna say Huai. Am I correct?
You have to
yeah.
calculate.
But in a real, actually, but in a real,
Only the density that less than 0.9
in a real, yes, in a
can
real
float.
test, in a real test, you should calculate
You
because
should calculate right now.
how am I supposed to know which one is three or which one is four?
A equal to mass divided by volume, right? 1 divided by 1.
And look
And
at the
take it out,
others.
take this one out. Delete.
Look at the others.
Substance A is
What?
1 divided by 0.9. Mass per volume density equals to mass divided by volume, right?
Teachers that I don't want to teach.
Look at the substance A. One. Substance A. dA equal to mass A. Mass A is 1 gram divided by 0.9. How about dB? Equal to 2 grams divided by
No, hiya.
what?
This is mass.
Yeah, this is math. You have to calculate.
This is volume.
Look at this. The density is gram per cubic centimeter, so we
Yes,
can use gram, no need to change.
I was going to tell you that I was going to use this method. So if sumut 1 minus 1 d equals 1, and then we compare that to this. Why do we have to use this as the mass? Why? I wonder.
You have to compare the density with the vegetable oils that had density 0.9. The substance that has density less than 0.9 can float on the vegetable oil.
I know.
We have to calculate.
Then why use 0.9? Why don't just use here, over here?
Look at this. This is 0.9.
Oh,
Substance A, right? Look at its graph.
oh,
Mass is 1.
oh,
And this one is 0.9. How about B?
oh,
Mass is 2. How about this
oh,
one?
oh, oh,
How about this one?
oh,
2.8, maybe.
oh,
Right? Over
oh.
there. How about substance C?
Uh,
3 divided by 3.8. Stop. Now calculate.
so lazy. Why you want me to teach empty people? You want me to teach myself? Hiya.
I want you to calculate how to find the density.
No, you kidnap me here to teach empty people, people with people that isn't here.
1 divided by 0.9 is
Uh, hmm?
multiplied by 10 both top and the bottom. This multiplied by 10.
Why 10?
Look at this.
Oh, I forgot.
How many are decimal point? How many positions?
Can
Only
I?
one position.
I want to think the top first. I'm too lazy to think that.
Doesn't it the top?
Huh?
This is the
I
top.
want to think about this one first, B and C.
B or C?
B and C.
2 divided by 2.8.
20 divided by 2 is supposed to
You
be.
still have to multiply by 10 both top and the bottom. So you get 20 divided by 28. What the answer? What? Ah? Is it 1?
1.
20 is less than 28. It must be 0.
Okay. Huh?
อุ้ยมาI'll stop recording first.